All right. All right, thank you very much. So my name is Delano Seymour, and today we're going to talk about how you can smash your servers. Now, smashing your servers from our point of view is putting servers away, not having to worry about them, not having to deal with them. So what we're going to do is show you how you can use EDJX to build and scale your servers on the edge. Now, my name is Delano Seymour. We also have David Sebek, who will be also presenting with me as a co-presenter. And then we have two other personnel, Adam and Venu, who will be there to answer any questions at the end. So first thing is first, what is EDJX? What do we do? Well, EDJX is a cloud edge computing system, that allows developers to build intelligent, low latency apps that are closest to the users than ever before. Basically, we want to help you build apps on the edge. So then the next question, I think you're probably asking us, why? Why build apps on the edge? Well, since the invent of the smartphone, more and more devices are being connected to the internet. We have smartphones, we have wearables for health. We have sensors that measure temperature and other ambient data. And all of these systems, we have video cameras, and all of these devices are generating data. These devices are not just generating small amounts of data, but in some cases, like video cameras, large amounts of data. And that data has to be transmitted and stored somewhere. That data also needs to be processed on. So the question is, how do we do that today? Well, we do that using the cloud. So if you wanted to send data to the cloud, you would process it on the cloud and then you get your response back. But is the cloud enough? With 1 trillion devices coming online in 2030, we're not going to have enough bandwidth to send all that data to the cloud and to receive it back. I mean, the cloud could take as long as 160 milliseconds. Sounds like a small number, but that's just too slow for what some of the applications require. So because of that, EDJX has set out to build a platform that allows developers to build apps that can run at the edge, close to the user, close to the device. Well, how do we do that? What is our solution? Well, we've created a system that sits between the cloud and the device. We sit there in the middle. And our goal is to put our nodes in as many different jurisdictions all around the world as we can get them. But not just in data centers in those jurisdictions. We want to put our nodes in places that you might not think compute should go, like a light pole, or on the side of a road, or on a cellular tower. We want to put compute everywhere. Why do we want to do that? Well, we want to do that because that gives you a low latency connection to that compute. Any device, whether it be on the side of a road, traveling down a highway, can connect to one of these systems, compute data, or store data, and retrieve the information they need back in order to do whatever it is they need to do. Your app's doing what it needs to do. So what are some of the things that we provide at the edge? Well, we bring some of the cloud services that you're familiar with. Object storage, for instance, being able to store data in objects, being able to store objects in the cloud, you can do that at the edge. We also bring serverless computing. Serverless computing allows a system, a person or application developer to write their code as functions. Instead of writing a full-fledged application, you write small functions. And these functions are executed based on events, things that happen. So as things happen around you, these functions can execute, do some work, and deliver a result. And of course, we want to be everywhere and anywhere. So we use things like 5G in order to get connectivity to our systems. Well, what are some of the example use cases that you might think of where you can use EDJX? We've created a sort of grid here of many different example use cases. autonomous systems, safety, transportation. You have geospatial grids. You have games or gaming. What about autonomous drones or AR, VR, or health and smart cities? These are a wealth of options or industries in which EDJX plays a good role to help you build apps for these industries. So how is the EDJX platform, how does the EDJX platform work? Well, first thing, we have built a system where we can put servers in lots of different locations, and we want to put those servers close to the devices that need that compute. For instance, you might have sensors out there, you might have virtual reality headsets, you might have industrial systems for temperature control, and all sorts of other things they have to measure to keep that system running. But all of those things can connect to one of our nodes as close as it can. And then we bring those services, those cloud services that we talked about, on those nodes so that you can use them right there at the edge. So this allows you to build applications that can scale in a massive way and still be close to the user that uses your applications. And with all of that, you don't lose any performance. So what if your data and your processing ran in the cloud, on the edge instead of in the cloud? What can you do? Well, one thing is you can connect to many sensors and devices, because all of those devices and sensors can connect to a system local to that device, compute their data, send data, store data, retrieve data, all in a place that's close to that device. So how do we do this? Well, we have what we call EDJURL. EDJURL is an operating system. We install that operating system on various servers and devices. Some of those servers live in data centers. Some of those servers live outside in the elements. And then we put those servers in different places. For instance, a hyperscale data center or a far edge hub, right? Where we have it on a light pole or near a street corner or on a cell tower, right? Or even in your own internal organization. You might need that compute closer to you, right in your own building. And then through our content address peer-to-peer networking, we can move data around from server to server. Servers don't have to participate or communicate with a central system in order to do their work. They are autonomous. So what do we want to show you today? Well, the question is, can you build apps on this type of system, this type of service? Well, we built one. We want to show you how we built it. And we want to describe the process that you'll go through to build your own apps. Well, let's talk about this app called EDJURL. Very simple app, okay? It does URL shortening. Now, you're probably familiar with that. Sometimes you get a URL that's really large and you want to tweet it out to someone, and Twitter gives you a certain number of characters you can use. Well, it'll be great if you can reduce the characters that the URL uses to leave space for other information. So you can shorten that URL. You can make it a shorter link. That's what this app does. Very simple, shorten your URL. But before we go into how that app works, let's talk about how EDJX works and how its functions work. So on EDJX, you would create a function, store it on EDJX, and then what happens is someone will make an HTTP request. When they make that HTTP request, it will hit one of our servers, one of our nodes, we call them. Then our system, using our DNS service, will triangulate where you are and then redirect your request to a node that's close to you, very near to you. We try to get as close as possible, like a mile or so. And then it triggers a function, or sorry, an event, and that event will trigger the function to execute. Now that function could be written in either Rust, or it could be written in C++, either one. And we're planning to add even more languages as we go. Now, you also have the capability, or the function has the capability to access the object storage that we can store on our network. It also can access what we call a key value store, and therefore use that as a database to store data that it might need in a transient way. And then when that function is finished executing, it will return a response back to the user. Now that response could be anything. It could be the output of some calculation. It could be, some file that you've converted from one format to the other. It could be anything. So now let's take a look at the EDJURL architecture. How does this particular app, put together? Well, first, in the top left corner, you'll see the storage. So that's object storage. Now we have a UI that was developed, a web UI, and we created that web UI using HTML and CSS and JavaScript. And then we uploaded those assets to object storage. Now our object storage allows you to host that actual content and make it available on the internet, which is great. Then we created two functions. One function is called shorten, and the other function is called fetch. The function that's called shorten takes the long URL and then converts it into a shorter URL. You'll notice at the right side, what's in pink, it converts that whole URL into a small code, and then connects that to the EDJURL URL. And then when someone goes to that URL, when they click on the link, then the fetch function takes over. It will go and take that key and convert that back into the long URL. Then it does a redirect and redirects the user to the actual website that URL is meant to go. Very simple application. That's our architecture for that application. So just to dig a little deeper in some of the features that were used to make that application. One, edge functions was used. We had two, shorten and fetch. Shorten was written in Rust, and we wanted to make it a good example. We wrote fetch using C++. And then the shorten function uses the KV store to store those codes that we converted your URL to. Then we have edge storage, which stores all of the HTML, the images, and any type of JavaScript. Then we have edge domains, which allows you to create a domain and host a domain with EDJX. So we give that capability as well. And as part of edge domains, you get request routing. So we can route requests from, say, URL A and reroute it to URL B. And we do that for the actual functions so that we can execute them. And we don't want to expose the long name, so we want to give you a nice, small, short name, edgeurl.com. And last but not least, we have the EdgeNet. EdgeNet's goal is to actually store and distribute all the assets, all the functions, the HTML files, and do that in a global manner so that it's available to you no matter where you are in the world. So let's now take a look at a demo of this. How did we build it? What did we do? What are the steps that we went through? Well, I'd like to hand it over to David Sebek, who's now going to show you how he builds this particular app. David?
Thank you, Delano, for the introduction. And I will show you how we can deploy the app. Can you see the screen? Okay.
Yes.
So the app consists of three components. It consists of the URL shorten function. That's the function we have written it in Rust, and it takes the URL, the long URL, and returns the short version of the URL. Next, we have the URL fetch function, which takes the shortened URL and returns back the original long URL. And then we have the HTML page, which serves as the user interface so that the user doesn't have to use the functions directly, but they can use nice interface. And then also we, as Delano said, we configure the domain so that everything is nicely put together and it works as one app. So first, I will show you how to build the first function, which shortens the URL. It is written in Rust, and I can simply build it. When I open a terminal, I go to the directory with the app, and it uses cargo to build the function. And
hey, David, would you be able to increase your font a little bit? Make it a little larger?
Yeah, is this better?
One step up will be even better. Yeah, there you go. Thank you.
Okay. So we compile the function into a WASM file. WASM stands for WebAssembly, and it's like a target architecture. And then we will take the WASM file and upload it to EDJX. So I will build it, I will compile it into WASM. One advantage of Rust is that we have all kinds of libraries available. Okay, so now it's built into a WASM file. And next, the function is compiled and I want to deploy it. So I go to the EDJX console, which is console.edjx.net. It looks like this. I select an organization. I created an organization just for this event called Lunch and Learn. And here I create an app. I go to applications and I create an application. I will call it EDJURL because that's the name of the app that we chose. Now I created the application, and the application consists of functions. So I have multiple functions, and each of those functions can be written in a different programming language, as I will show you. So right now I will create a new function. It was written in Rust, and I will call it shorten because it shortens the URL. I will allocate some memory and set the timeout. And this is the most important step. I select the WASM file that I just compiled. So that's the shorten function. And it was compiled into this WASM file. That's the binary, that's the function. Okay, now the function is deployed. It's deployed on EDJX, and it's globally distributed. One thing I need to do is it uses a KV store to store the URLs. So I need to set a permission to give it a write access to KV store. And now I can take the URL of the function and I can run it. Can you see this, or should I make it bigger, the font?
You can make it a little bigger. Yeah.
Okay. Yeah, so I pasted the URL of the function. It redirected me to the closest node that's the closest to me, and it executed the function. Because I didn't provide any URL, it gave me this message, and I can provide the URL to be shortened. For example, https EDJX.io, and it returns this short string. And yeah. So this function works. And next we need to deploy the second function. The next function is written in C++, and it takes this short string and returns the original URL that we shortened. So I go to the, yeah, this is the function written in C++. I go to the function directory. And this one can be built using a make. It has a make file. So I just run make all, and it builds the function. Again, it builds it into a WASM file. Now I will take the WASM file and I will create a new function. So I'm still in the EDJURL app, and I will add a second function. Sorry. Yeah, I'm in the EDJURL app, and I will create a second function. This time it's in a C++, and I will name it fetch. I will again select some memory and set the timeout. And then I select the WASM file. And create the function, and the function has been created. I can take
the policy, David. Don't forget the policy.
Oh, yeah, thank you. I need to set the KV start policy again. This time we just need the read access. We don't need to modify any values. So I set the policy, and now I can take the URL of this function, and I can execute it. And when I use this shortened URL that was produced by the previous function and give it to this new function, it will redirect me to the original EDJX website, to the original URL, as you can see. So now we have two functions. We can shorten a URL, and we can retrieve and redirect to the original URL. Next, I need to deploy the user interface, the HTML page. So first I will write down the URLs of these functions, because it will be useful later. And now I can go and create a bucket. So bucket is a place where I can store files. Again, those files will be distributed across the EDJX nodes. And yeah, first I need to, so the web page is a simple HTML page, and it uses JavaScript to call the functions that I deployed. And I need to update the URL of the function. So I need to take the shorten function and put it here so that the JavaScript on the web page calls this exact function. And I will save it. And now I am ready to deploy the HTML page and all the images and other files that belong to it. So I create a new bucket. I name it EDJURL just to stay consistent, but it can be anything. And it needs to be publicly available. and create. And then I will upload the HTML page or all the files that belong to the HTML page. So it consists of images, the HTML page, then there's a file with the JavaScript and also CSS for styling. So now I have all the files in the bucket on EDJX. And by default, so each of these files is accessible via a URL. Each of these files has its own unique URL by which I can access the file. By default, it would download the file if I go to the URL. So I need to set this content disposition header to inline, so that when I visit this file URL, it will display the file, the HTML page, instead of downloading it. So I can try that. I can copy the link to the HTML page and I can paste it in the web browser. And it displays the HTML page. I can try and I can do something simple. I can again do EDJX.io and I can shorten it, and it will call the shorten function and give me this short string. And it generates a different string each time. So when I shorten again, it generates a different string. So next, I need to configure the edge URL domain, because right now I want the edge URL domain to redirect me to the fetch function. So again, I think I can copy the URL of the home page just for my records. Okay, and now I can add a domain. I can go to domains and create a domain. I already created this domain. It's just in a different organization. So I did this. I added the edgeurl.com domain. Right now it's not configured. It doesn't return anything. And I will add request routing rules. So I will create a rule. So first rule is I need to display the HTML page. For that, I need to create a rule. I will name it homepage. And it will exactly match the HTTP edgeurl.com. And it will redirect me to this homepage. So now I created the rule, and when I go to edgeurl.com, it will redirect me to the app homepage. And the next thing is I need to make this fetch function functional. So I need to add another rule. I will call it fetch. This time it will match a pattern. So I need to Yeah, so I will need to match every request that goes to http EDJURL.com and / yeah, this. And anything that goes, this asterisk matches the actual request that it receives. And it will redirect to the URL fetch function. And I need to append this, the part that's symbolized by the asterisk at the end of the URL. So it will call this. So it will just take the short string and append it to this fetch, send it to the fetch function. And now I can test when I take this shortened URL, it should redirect me to EDJX homepage. Yeah, it did. And I will show you one more link. So this EDJX.io, it's not very long, so we don't need a shortener for it. But when I get some very long link, for example, this one is longer, I can paste it here, shorten it, and it generates a link that is much shorter, and it will redirect me to the, so it will redirect me to the original URL. So that's the same. So that's how our example EDJURL app, how it works and how we can deploy it.
All right. Thank you, David. And I'll go ahead and share my screen now. All right, so we just finished looking at the demo. I hope that was clear. We, of course, will have questions, so you can ask us any questions you wish. I just want to mention that EDJX is onboarding developers now. Come join us, sign up. This is our URL, console.edjx.net/login, or you can go to edjx.io and you can click the login there. And IoT is going serverless. Different like wearables is going serverless. Lots of things are going serverless. And we want to be there as EDJX to help people to build those apps on the edge, because that's where it needs to be for latency. So that's it for our presentation. Thank you so much. And we'll like to entertain any questions that you may have.
Wonderful. Thank you all so very much for that presentation. Does anybody have any questions? I don't see any questions in the chat. Oh, I'm starting to get some questions in the chat. So the first question is, what does a schema look like with this model compared to DynamoDB or Snowflake, for example?
So for our key value store, which I think is what you're referring to, you can basically everything's like a standard key value store. You push in keys, and then those keys have values. And if you want to query for a particular value, you just use the key to make that query, and it brings back that value. So basic key value stores, key value database.
Other questions? Are there edge nodes deployed? How could one test latency or edge offload?
So we do have edge nodes deployed in about 22 different locations around the world so far. Of course, we want to expand that. So we want to get as many as we can out there. You can test latency by just building one of our functions. And if you want to put something on the website or the browser and test latency to that function and back, I think that would be a simple test to test any of the latency.
How about, is Python one of the languages on the roadmap?
Yes, we are working towards adding Python, but that language will require some work on our end because it's not a compiled language. It has a runtime. So we're working to add that as well as JavaScript. JavaScript is another language that has a runtime, not compiled. And so we'll be adding both. We're working to add both Python and Java in our roadmap, JavaScript in our roadmap.
Cool. Other questions for the EDJX team? Okay, well, seeing none.
Excellent.
Oh, someone.
Now, don't be shy. We're here to answer any questions you have.
Oh, okay. I have another one. As an example, with AWS, you can use DynamoDB in order to create, store, and query records through Lambda functions from the API gateway. With EDJX, are there records stored inside these key values? How are they queried? And do Rust functions act as Lambda functions if we consider the AWS model?
Yeah, so very similar to the AWS Lambda model. Our functions are very similar to that. So you would have code, you deploy that code, it executes. Now those functions that have that execute have access to our key value store, where you can read and you can push content to that key value store. You can read that content back through the functions. So you could do that with any function all day long, really. And those functions are deployed on our entire network. So no matter where you are in the world, that function can be executed in that location, therefore given low latency in that location, which is slightly different from how Amazon does things, because a lot of things are in a particular region where our stuff is everywhere.
How is data synchronized across locations?
Yeah, so because we have a peer-to-peer network between our nodes, we have built a system that allows us to use a protocol. It's called a whisper protocol, which says, if you think in your mind, you've got server A receives a file, somebody uploads a file to server A maybe in India somewhere, right? And that server in India sends out a message saying, I just received the file, and sends it across the entire network. And so someone somewhere else on the network says, oh, I don't have that file in my repository and I might need it. So it will make a request to India and say, please send me a copy of that file. Now, we don't do it at the file level, we do it at the block level. So we go down a level. So we take a file and break it down into blocks, and those blocks are distributed across our network. So that at any given time, more than one server has part of or all of your file, and therefore we can constitute your file at any time, at anywhere on our network. Hope that answers the question. It's got a little bit complicated there.
Awesome. Looks like it did. So.
Okay. Awesome.
Any other questions from anyone?
If I can just jump in as oh, good, we have more questions. Please go ahead and then I'll say something.
Are nodes validated through Notary?
So yes, we do have a Notary. So I don't know if you noticed it when David was doing a demo, there were some other options that you can tick when you push a file. One of them is a Notary. So what that does is you say, I want to notarize this file. It will then wait for 3 other nodes to get the exact same file. And all our files are stored as hashes. So therefore we can verify that nothing has been changed in that file. And then we verify the hashes across 3 or more nodes before we consider that file stored and saved. So that's how we notarize it. And then the other one was pinning. So you can say, I want this file to always be in India. and you can pin that file to India or pin that file to, United States or wherever you want that file.
How is this model different from blockchain, and how is it similar?
Okay, so it's very similar to blockchain because we use a peer-to-peer system like blockchain. All the nodes work autonomously like blockchain. Like they don't need a check-in or home base or anything. Also, the nodes make up the network, like how blockchain, the nodes make up the network. What's different from blockchain is that we do have a central system, but that system is more like a control system. It allows you to access the API. It allows you to access the console. But once you push a particular file or whatever to our system, it sort of steps away. It's just sort of a front end to the whole system. So that's probably how we're different. And also we don't use any type of like proof of stake or any of those validation systems. Like we don't use any of those. Proof of work, that's the one I was trying to get. Proof of work or proof of stake, we don't use any of those. Which makes it fast, by the way.
Next, another question is, what is your consensus protocol, if not POW or POS?
Yeah, we don't use any we don't use proof of work or we don't use proof of stake either. I don't think we have any consensus like that. Our consensus really comes down to the fact that EDJX controls everything from that central system. So we only have one way to get data into the system. And every time you push data into the system, it gets signed by a specific system. And that signing tells all the other nodes that this is valid or not valid. And all of our nodes have certificates as well. So all of our nodes have to connect, they get a certificate. That certificate can be revoked at any time. And that certificate gets refreshed on a constant basis. So nodes can't go rogue on us type thing.
Okay, and then next question is, what data is mutable and what data is immutable, if any?
So the way our system is designed is that mostly all of our data is immutable, right? You can put in a file that is immutable once it hits our system. If you want to change it, you have to upload a new file or a new version of the file. And then that creates another hash. And then that's immutable. So our complete system is basically immutable. Things only change by adding new items to our system. And because we work at a block level, if you upload a file A and then you upload another version of file A, we look at the block level. So we only store what's changed between those two versions, not the whole file. Any other questions?
So it's a lower level than, for example, ABI code?
I would say ABI code is a different beast from what we do, but it is lower level. It is low level. Most our whole system, we're not operating at the file level. We're operating way down at the block level. So a block might be like 2K, 3K, and you might upload a file that's 5 megabytes. Well, we're dealing at the block level and moving that around the network.
Okay,
It's everything.
I think so.
Excellent.
One last thing, if I may. Hi, everyone. I'm Laura Roman, CMO of EDJX. I wanted to say quickly, this is an exciting time for us as a company because EDJURL came out of an internal hackathon that we ran very recently. It's one of 5 apps, and our team spun up these apps so quickly, and they're all so good. We could go to market with them as a company. So two things from this. We would love for you to sign up here and just kick the tires. At this point, as Delano said, we are en route to onboarding other languages, en route to Python, en route to JavaScript. Right now, come on board, build what you can. We'd love to get your feedback. And then second, we are hiring a developer evangelist. We have a full-time role and then a couple of supporting roles. We would love to talk to you about your interest in evangelizing us. It's a very exciting time for the company and we're just exploding from here. So if you have any questions, ping any one of us or ping Jen and she can forward it on to us. Thank you.
Okay, everyone. Well, thank you all so very much for joining us today. And thank you to the EDJX team for presenting and chatting with everyone and answering questions. I hope everyone has a great rest of your day and we will see you at the next Lunch and Learn. So, bye, everyone.
Thanks,
Thanks
Jen.
a lot.